Okay, hello. I'm Josh Karlin from the University of New Mexico. This is work that I did with my advisor, Stephanie Forrest, and Jennifer Rexford at Princeton University. So I was here at NANOG 37, where I presented my work, Pretty Good BGP. It got, I think, pretty good reception and some criticisms. In fact, I wear it with a badge of pride that Randy Bush came up to the mic and said, "Don't listen to that guy." Overall, though, I thought it was good, and I got a lot of good response. And thanks to that, I've now gone back and made a second iteration of Pretty Good BGP. And I have a new set of tools that I'd like to present to you today. So first of all, as a recap, what was Pretty Good BGP before? Well, the basic idea is autonomous security for autonomous systems, right? And that means you can deploy a security system for your autonomous system without worrying about and relying upon other autonomous systems to do the same. So this means no public key infrastructure. It means not revealing sensitive information to the public and registrars. And primarily, it means immediate protection, significant immediate protection for early adopters. Otherwise, why deploy? Who's going to deploy it? And the way we approached this was, first of all, we looked at a small problem and said, let's just look at hijacks, prefix and subprefix hijacks. And we broke it down into three problems. First, let's detect them. And once we've detected them, we'll let operators know that, hey, look, here's a potential hijack. You should know about it. But that's only so useful because, well, the hijack's already propagated. You would rather the hijack actually was suppressed. So here's what we did. We came up with a detector. This is a history-based detector that says, these are the origin ASs that we've seen for each prefix over time. If I see a new origin AS for a prefix, well, guess what? That could be a hijack, right? We mark it as suspicious. We notify operators of the problem with the Internet Alert Registry. This is a website that's now been live for over a year. It has dozens of operators currently subscribed from Tier 1 networks on down. And it lets the origin AS of the AS being hijacked and the one performing the hijack know about the problem. These are the relevant ASs that can actually do something about it. So, okay, now we've notified operators. But it's better, as I said, if you can actually suppress the propagation of the route. And so what we do is we say, all right, put Pretty Good BGP, the detector, on the routers themselves, and then once they detect a suspicious route, depreference it for 24 hours. Note, I did not say discard it. Just lower its preference and try to use the more stable, trusted routes if you can. Giving operators the time to fix the route before it can propagate. So a lot of the criticism I received was that, you know what, there are ways around this. Yeah, the idea was to say, well, why don't we handle misconfigurations first? We've done that, but what about a malicious adversary? Someone that could instead say, well, I'll just prepend the legitimate origin AS and then send that off, right? So that's what I'm going to call a spoofed edge, a path that includes a link that doesn't actually exist in the topology. Next, what about policy violations? What if an AS propagates a route learned from a provider or peer to someone other than its customer, say to another provider or peer, right? We should be able to detect that and stop it if possible. So that's what we did. First of all, I just want to show you how effective each form of quote-unquote attack might be. So subprefix hijacks on an unprotected network with an unfiltered network are very problematic, as you can imagine. Prefix hijacks are a little bit worse. And then now we're looking at the lower end of the spectrum, the spoof prepends and the policy violations. So now, where is Pretty Good BGP today, and what tools do I have to offer? Well, our detector now looks at hijacks, spoofed edges, and policy violations. The Internet Alert Registry, which once would send you an email for each positive suspicious route, can actually be configured to only give you positive notification. And finally, we're actually looking at building this thing. I've been developing this in Quagga Zebra for not too long now. It's not all that big a hack to the router, quite frankly, and I'll talk about that. All right, so what did we have to do to the Pretty Good BGP detection algorithm to find spoofed edges and policy violations? So this is actually really easy. This goes right along with Pretty Good BGP style. You just say, okay, for the last 2 months, what are all the edges that I've seen in paths, right? Keep track of them. And then if you get a new route with a new path that has an edge you haven't seen before in the last 2 months, you flag it as suspicious. And in response, you again depreference it for 24 hours. So as an example here, you can see in the past we've seen path ABCD. So now we know and can trust AB, BC, CD as valid edges. And then we receive a new path, ABD. Well, AB, that checks out. We've seen that before. But BD is new. That could potentially be a spoof prepend, right? The nice thing about this just simple edge detection algorithm is that it can actually detect policy violations as well. So intuitively, just think about it as the fact that a route learned from your provider or your peer should only be sent to your customer. So that edge from you to your provider or peer, in this case I'm going to call that B to C, should only ever be seen by your customers. Your provider or peer should never see the edge in that order BC. Note that CB is a different edge from BC, right? So in these three examples, ASA will always be receiving a new edge, which is BC, and we'll detect that as a spoofed edge or a policy violation. All right, so that's the new detector. Now the tools. The Internet Alert Registry. It's been going strong, and for all this time has been sending out emails to operators. And I've made one slight change to it, which is I just added an RSS feed of alerts, which is, nothing big. And I don't recommend that operators actually try to, subscribe to the RSS feed and read them all. It's a waste of time. In fact, I think instead you should run a program called the IrTrekker, which reads your BGP configurations and then reads and scans the list of current alerts and will only not notify you of true positives, right? So you've configured this thing on your end. It's running on your host, and will find the true positives in the list of alerts and send you an email. You don't have to deal with false positives whatsoever without revealing any network information because you're doing the scan anonymously. All right, so why should you care? Does it actually work? So the questions you might ask are, is it effective? Are there a lot of false positives? And if so, how will these false positives affect my network? Well, it is immediately effective for each autonomous system that deploys the router change, right? Because you're suddenly, for 24 hours, protecting yourself from all possible hijacks, policy violations, and spoofed edges. A more interesting question might be, what if we just partially deployed this on the internet? What if, say, only a few ASs were to deploy this? What global benefit could the network see, or the internet see, right? So I did this simulation. You have, on the x-axis, the number of autonomous systems that have deployed pretty good BGP, in order of largest ASs to smaller. And on the y-axis, I've actually performed a bunch of simulated attacks, and we see how effective they are. So without any pretty good BGP deployment and no filtering whatsoever, you see that subprefix hijacks are completely effective, prefix hijacks, half that, etc. But as pretty good BGP is deployed, you get to say, let's say 100 ASs have deployed. These are the 100 largest ASs, mind you. You'll see that actually the effect of these attacks is mostly minimalized, in fact, pretty much negligible. And that's 100 out of 25,000 ASs independently running this. All right, next question. Are there a lot of false positives? Yeah, there are. The IAR discovers, like 150 to 200 anomalies per day. The large ISPs would receive 1, maybe 2 emails a day, which is nothing for their NOC centers. And then those on the periphery might receive 1 a year. Again, if you use true positive only notification, you don't care what the number is, you want them all. So then the question is, okay, there's a lot of false positives, but how will they affect my network? Well, first, keep in mind that reachability isn't lost. You're depreferencing routes, not discarding them. So if there's a flap or an edge goes down, and suddenly you see a new edge or a new origin AS for a prefix, you'll route to it if you don't have any other choice. But the idea is to trust and use the stable routes. And the next thing is that most of these false positives, or positives in general, actually don't last long. They don't stay in your router long. Most of them will disappear within the first hour, and then a good majority over the next 24 hours. Most don't last to the full 24. So to conclude, I'm trying to impress upon you that it is possible to protect networks without global cooperation. Pretty good BGP is a simple anomaly detector coupled with a soft but effective response mechanism. The IAR has been around for over a year. Operators have been using it. You can test it right now. And we're working on a prototype router implementation. It should be available soon. The University of New Mexico's ITS department has been kind enough to cooperate with me and help me test this. And additional help from you would be really appreciated because I don't have any resources. I'm a student. This is my dissertation work. And thank you.
AP Nick. A very quick question. You just said a second ago most of the things you see last for less than an hour.
Yeah, well...
that one?
Yeah.
How many of them last for less than 65 seconds of the ones that last for less than an hour?
That's a really good question. I don't know the answer.
Because part of the issue about false positives is actually BGP's path exploration to withdrawal,
sure,
where you actually explore paths you wouldn't normally see, yep, simply because you're doing the BGP dance.
Right.
And if you actually had a timer that said, I'm going to ignore these things for a period of time until I'm satisfied it's not part of path exploration, how many of those would you get rid of, and what would be the certainty factor of what's going to get left as distinct from what you're doing now? You see what I'm saying? That there are transient paths that appear simply because BGP is doing the normal thing, and
right,
they're purely transient, you can
right,
ignore them.
Right.
But if they stick in your router for a longer period of time, it's actually someone doing an advertisement, not BGP dancing, and that's the ones you're actually interested in.
Yeah,
and then you get into the next question. If you're going to do any kind of update suppression, rather than alerting, you simply don't propagate. How many of these would you not propagate, and why? In other words, could you use this rather than doing an alert to actually doing damping of updates? It leads you into fascinating places about update load, you see. And what I'm trying to sort of point out is that if BGP had an affinity for stable paths, mm-hmm, and it saw other paths and said, I'm going to wait for a while before I propagate, mm-hmm, because I think it might be a transient expiration, how many updates could you remove from propagating onward?
I have no idea.
About 30 to 35% are candidates, by the way, as a clue. So you're onto a really interesting thing here, is what I'm saying, and I think it leads in a lot of places.
Scott Librand, Internet. You mentioned that this protects against sub-prefix hijacks, but it does so while only changing local path. How's it possible to ignore longer?
I danced around that issue because it's the one part that's slightly different from the rest. Sub-prefix hijacks, it will look for a new prefix that happens to be a sub-prefix of a currently existing route in the RIB. And if it sees such a thing, it can't just depreference it. What it does is it continues to route to the super prefix, or the greater net, for 24 hours. So this is the one small area, corner case, where you might possibly lose reachability.
Okay, so you are modifying the underlying BGP selection algorithm, not just changing the administrative parameters.
It depends on how you suppress it. In that case, you might even be considering filtering it, and that's not a decision process thing. It depends on where you put it in the router.
Fair enough.
Christian Vogt, Ericsson. Jason, you have this 24-hour time frame that you use for degrading the preference of a route. Do you have more rationale for this time frame, or is it a number that is just easy to handle? Or, I mean, you have this. You were saying that after 1 hour, most anomalies actually go away. What is actually the percentage of anomalies that have been gone after 24 hours? Is it that?
It depends on the type. So as you can see in this graph, the sub-prefixes tend to actually be legitimate more often than new hijacks, or prefix hijacks. So maybe about 20%, 30% actually go on after the 24 hours. And I forgot the first part of your question.
Well, basically the two, it's related. I was just wondering what rationale you had for picking
why the 24 hours? That's simply so that operators can respond. I mean, we're all on a different clock, so you have to give people enough time.
Okay. Thanks.